Okay, so when you're graphing trig functions, there's two methods you can apply. Either method 1, you just plot your points directly, or method 2, where you use a table. Okay, so let's look at the example. Y equals -3 sine 1/2 x plus pi over 4 minus 6. What do you notice? It's not factored. It's important you notice this and factor it out, otherwise your graph would be totally different. So let's factor y equals -3 sine 1/2 x plus, you divide pi over 4 by 1/2, you get pi over 2 close bracket minus 6. Okay, so now let's use method 1. Your amplitude is your A value. So 3, you don't need a negative. Your axis is your C value. So -6. Now you can determine your maximum and your minimum values by using your axis and your amplitude. So axis plus amplitude gives you your max, -3. Axis minus amplitude gives you your min, -9. Your phase shift is pi over 2. Notice if you didn't factor, it would be pi over 4 and then your graph would be wrong. To the left, your reflection exists on the x-axis, and your period is 1. You can determine it because the k value is 1/2, so 2 pi over p equals 4 pi. Your period would become 4 pi. Okay, so let's graph this out. Okay, so when you're graphing and you want to determine your x-axis, you look at two things. You either look at your phase shift or your period. And since the phase shift is pi over 2 and the period is 4 pi, what an appropriate x value increment would either be pi over 2 or pi. Let's use pi over 2 because it's simpler to see. Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and 7 pi over 2. 4 pi. So already done on the other side. Okay, so now we can plot our points. Our x-axis is -6. Plot that. Okay, maximum is at -3, minimum is at -9. We went up by 3s on a y-axis scale because it's simpler and easier to see. Okay. So now since we're dealing with a sine function and there's a reflection, we start at a sine and then we go down, but there's a phase shift pi to the left, so we'll start here, then we'll go down. Since our period is 4 pi and we're going up by pi over 2, for every 2 points we go over, we either go to a minimum, maximum, or the axis. So it would be pi 2, where we reach the minimum. 3 pi 2, we go back on the axis. 5 pi 2, we go to the maximum. And 7 pi 2 back on the axis. Just graph out the first cycle. This makes sense because it stops pi over 2 before 4 pi, and since we shifted pi over 2 to the left, you can see how this would make sense. And then it gets down. And when we do this sign, it's important you put the arrows at the end to show it's continuous. Okay, so now let's use method 2, the table method, for the same graph. For the x-axis, the transformations applied are half x minus pi over 2. It's important you put the minus in because you're going to the left. And for the y, it's -3y minus 6. Okay, so for 0, it would be -pi over 2 because the product of anything is also 0 and -6. And for the other values, I'll just fill it in. You can calculate it in your calculator. 3 pi over 2, 5 pi over 2, and 7 pi over 2. This is for one cycle. So let's see if the points are the same. This isn't exactly which maximum. At negative pi over 2, we're at negative 6. Good. At pi over 2, we're at negative 9. Good. At 3 pi over 2, we're at negative 6. At 5 pi over 2, we're at negative 3. And at 7 pi over 2, we're at negative 6. And you can see, well, my sketch is pretty bad, but they're exactly the same graphs, identical to each other. All the points are the same. And you can just keep going. Once you have one cycle, you can determine all of them. And see how by using either method 1 or method 2, you can apply your transformation to your graphs to graph your new function.